Hi, good day. So I'm looking today at my second video, so to speak, on the binomial expansion formula. Um, so I will not be looking at the range of validity of the binomial expansion, since we are going to work with positive integer for n, and what we're going to do, we're going to work with the special cases of 1 plus x, 1 plus something, but we are going to also then look for other unknowns. It could either that you have to find n or some other things as well that are within our binomial. Right, I just maybe want to look quickly at, let's suppose you were to expand this using Pascal, and you should be quite familiar with that since I have been doing Pascal's one, and then that will be in this vicinity over here. All right, that will be like a typical a plus b raised to the power 4, which is what this is. All right, our a is nothing but 1 here, so that will be 1 raised to the power 4. Well, of course, I don't have to write the x, but x to the power 0. The second coefficient will be 4, and then x is now increasing. As x is increasing by 1, then not x but rather my 1, my a value, okay, my a value happens to be 1 a value, so that's 1 is now going to have decrease, and my x is going to gain 1. My next coefficient is 6, and I'm going to have my a value, which is 1, is going to lose 1 more, but my b value of the x here, the b value of the x, is going to gain 2 more, and then I have plus 4, and then 1 to the power 1, of course, x cube, and then plus the last one is going to be, my coefficient is 1 here as well, but my b value, which is this whole x here, is going to be x to the power 4. Okay, so let's clean this up and see what does it give me when I was if I'm using this. So this is nothing but 1 here. This just gives you 1, and here I have nothing but 4x. If you were to do this here I have nothing but 6x squared. Here I have nothing but 4x cubed, and here there's nothing but x to the power 4. So this is how you would otherwise expand that using the binomial theorem. Now, there is something else, of course, that we can use, and that is what we refer to as n choose r. So, n choose r, which is based on n factorial over r factorial, and then n minus r factorial, which we can use to find these coefficients over here. We can find these coefficients using this. So in the place where we are using Pascal, we can use this, and I want to show you something there. Okay, um, so uh, for let us do for choose. Let's say we do for choose 0. Okay, and that will be the 4 being here. All right, so for choose 0. So I have maybe use something a little bit. Okay, so that is going to be 4 factorial over 0 factorial and 4 minus 0 factorial, which you know it is 4 factorial over, well, 0 is just 1 factorial. Very important that you should know that 0 factorial is equal to 1. So that is 1, and 4 minus 0 is just going to be 4 factorial, which is the same thing divided by the same thing. It always gives you 1. Now you can see that is the coefficient that we have here, similar to the one that we have in the first case. Let's do the second one. Okay, the second one. So let's just go back, and then I have 4 choose 1. So 4 choose 1 would be 4 factorial over, well, you're going to have 1 factorial and 4 minus 1 factorial. You should also know that if you have n choose 1, this is always going to equal to n. So therefore, something like 4 choose 1 will give me 4. But let's go ahead and show that. So that is 4 factorial. Well, 1 factorial is just 1, so no need for me to write it down. And then here I have 4 minus 1 factorial. So that is going to give me nothing but 3 factorial. So remember, this is nothing but 4 times 3 factorial over 3 factorial. And if you were to go ahead and cancel out, you see that I am going to get 4 as an answer, which is that other coefficient that I was talking about. And you can see obviously from our previous work, that is the coefficient. So I have the first one, I have the other one. Let's do the one for 6 as well. So the one for 6, well, of course, that is going to be 4 choose 4 choose 2. So this is nothing but 4 factorial over 2 factorial and 4 minus 2 factorial. This is 4 factorial over 2 factorial, and 4 minus 2 is 2 factorial. Of course, this is going to give you nothing else but 4 factorial over 2. Now 2 factorial is nothing but 2 times 1, which is 2, and I'm going to multiply that with 2 factorial. In fact, I don't have to do that, so that maybe you don't say, well, now I'm confused. So I'm going to leave it 2 factorial and 2 factorial. On top, I want to say 4 factorial is nothing else but 4 times 3 times 2 factorial. That's where I'm going to end. All over 2 factorial, 2 factorial. Of course, I'm trying to squeeze everything in there. Now 2 factorials, they cancel, leaving me with 4 times 3 over 2 factorial, which is the same as 4 times 3 divided by 2. Well, 4 times 3 is 12. Half of 12 is 6. And if you were now to look, you will realize that, of course, that is the coefficient that I was looking for, the next one. And so that will be the 6 over here. And so I can continue and I'll find the 4 and I'll find the 1. So I'm going to use that concept when I have this. Let me take that same expansion, the expansion of 1 plus x raised to the power 4. It's quite special because you have a 1 over here, all right? But this is positive, so I do not have to worry about anything else, all right? So using what we have from there, we know that the first term is always going to be 1, okay? The first term is always going to be 1, but if we need to do it, we are going to do that. So the first term, which is 4 choose 0, which is this one that I'm talking about, is always going to be 1, irrespective or regardless of what we have there. But again, I don't want to put that down there, so I'll just put 1 there. And the second term, maybe for those of you who don't quite get it, let's just put it so that you can see. So 4 choose 0, we know from our work before, 4 choose 0 was nothing but 4 factorial. I'm now over here. This is the stuff that I'm referring to. It is 4 factorial over 0 factorial there. So I'm going to write that down. So it is going to be 4 factorial over, so 0 factorial, and then 4 minus 0 factorial. Okay, that's what that one was. This is the coefficient, right? The coefficient. So the coefficient, this one is going to be 1. That is our A, and our B. So this whole coefficient is now raised to the power of 4, but anything here raised to the power 4, and then our B is going to get the B value, which is the X over here, okay, is going to get its own, so X to the power of 0, right? Remember that it's X to the power of 0, and this whole thing over here is obviously like to the power of 4, okay? So, but there's no need for me to keep on rewriting that whole thing, right? For me to realize that, of course, it's just going to generate that. The next one, next one perhaps it will be best if one could maybe use an n for me to explain that concept. But the next one obviously is going to be, let's rather do something like this because I already have done that. So let's make that raised to the power of n. Then it will be better for me to explain. So the first term we know must be 1. The next term will be nx, the n being obviously what you have over there, and the x being, like for example, in this case, our n is 4. Can you see that? And that is exactly the n that I have. So I'm here, the nx is there, and the 1 is here. So to find the next one, for example, in terms of n, the next one will be, as we have seen, next coefficient will be n minus 1 over 2. I will leave it factorial, and then I will have an x square over here because the powers of x will increase, the powers of x being the b value, right? Remember, it's like a plus b. And the last one that I'm going to do there is nothing but n minus 1. Just rewrite that one nicely. So this is n minus 1, n minus 2 over 3 factorial, and that's going to be x cubed. Now have a look at the pattern here. You have got 2 factors on top, 2 factorial, 3 factors on top, 3 factorial, and look at the x square also correspond with the 2 factors and so on. Okay, so the next one, and as I continue, eventually this continues all the way. So we're not going to go for these practical examples that we're going to do. We're not going to go past the third one, n choose 3. So that is basically, it goes on and on, hence because this value here is positive integer. Right. So if I now have to use what we have done from our work with, just to prove again, it was 1 plus x raised to the power of 4. Substituting there, of course, I know 1 is here, and then n being 4x, and then I have got n, which is 4 minus 1 over 2. 2 factorial is just 2. X cube, and then plus, let's bring in one more, which is 4 minus 1, 4 minus 2, and over 3 factorial is 3 times 2 times 1, okay, x cube, and so it goes. And let's see what do we get here. So we've got 1 plus 4x, then plus, so you have got 4 minus 1 is 3, 4 minus 1 is 3. 3 times 4 is 12. Half of 12 is 6x cubed. Then I have got here 4 times 3 times 2. Okay, that's 24 divided by 6. And okay, so you have got 4 times 3 times 2. It's 12 times 2 is 24. 24, half of 24 is 12. 12 divided by 3 is 4. So you're going to have 4x. Sorry, this one here must be x squared. So that is x squared, 4x cubed. In fact, since this one will end because it goes up to the fourth, up to n when n is 4, I will definitely get everything as I go. So it will definitely end all the way to like the way I have it over here. Okay, so if I was to continue, I'm going to arrive at that final answer because it goes up to there. Okay, right. Of course, if you want me to do that, we can do that as well. Now that you have that, we're going to use this concept to solve a few questions. Questions like this one, for example. Okay, this one is quite simple. You just have to expand. Again, it will end because you're going all the way up to 3. So how do we expand this one? Well, this one should be very straightforward for us to do. Okay, using what we know, the formula is on top, so this is going to be nothing but 1, and the second one is going to be, well, the power, which is 3, and times 2 over 3 x, okay, using this part here. Then I have plus, our n is 3, then 3 minus 1 over 2 factorial, 2 factorial is just times 2 times 1, by the way, and then again 2 over 3x, this is now squared, plus then again our n, which is the third one. I'm going to continue. So I'm here, our n is 3 bracket 3 minus 1, 3 minus 2, and that is all going to be on 3 factorial. So perhaps I should just make more space because I'm running out of space. So I'm just going to continue on this side here. So we're going to say plus um, n, which is 3. So I'm now at this particular part. That is 3. 3 minus 1, 3 minus 2 over 3 factorial. And then my value here is going to be 2 over 3x. And now it's going to be cubed. Okay, that's where I'm going to end because it's finite. So let's just clean this up and see what we get. Okay, so it's going to be 1, that's what you have, and then here you're going to have nothing but 2x, so plus 2x, because the 3's they kind of cancel. Okay, so very important that you can see that the 3's cancel. And on this one here we have 3 times 2, which is 6, and half of 6, so half of 6 is 3. So if we were to do that, I'm going to get, again, as I said, this is 3 times 2 over here, that is 6, half of 6, right? That gives you just 3, but it's 3. And then in the bracket now, be very careful because you're squaring everything. That is 2 squared, which is 4, and 3 squared, which is 9 over x squared. Okay, I'm going to come back and clean this up again. So let's get to this one. Now remember, 3 factorial is nothing but 6. So on top I have 3 times 2 times 1, so that is 6 here, and 6 divided by 6. So that's this whole thing here will just give me 1. Okay, so I have then to only worry with this. So I have got 2 cubed, which is 8, and 3 cubed, which is 27x cubed. Right, so that's where it's ending, but there's still the middle, the one here where the 4 over 9 and the 3 that I can still sort of clean up. I have 1 plus 2x, then I have plus, of course, very important to realize that 3 goes in itself, then it goes there 3 times, okay? So I have nothing left but 4 over 3, and that is going to be x squared, followed by 8 over 27x cubed. And that is the answer for that, okay? Just as a teaser, using that binomial series formula. Okay, let's bring in about questions where we are now creating simultaneous equations and using that more to our advantage. So one of the things that I was now referring to, I was saying that we are not going to have to do this pass and choose 3. Okay, we always like to keep it within range. So we are asked to find the value of the constant n, and remember it's positive, and find the coefficient. So there's something again there, the coefficient of x squared. So we should find the value of the constant n. So first thing that I'm going to do, I'm going to take this part because I have now enough practice of what I have with this type of special binomials. Okay, so I'm going to take that part and I'm going to say, okay, we have now realized that that part is 1 plus nx, our x is x over 2, plus n minus 1 over 2 factorial. Now 2 factorial is just 2, and now this is going to be x over 2 all squared, and then plus, maybe to throw one in there, and it might not be necessary to go so far, to be honest with you, because remember I said and choose 3, so I'm going to stop there, and so on and so on. Okay, let's just clean this up. So I have now I have 1 plus nx over 2, and then plus, right, this is going to still be n minus 1 over 2 factorial is also just 2, okay, and this is nothing here but x squared over 4, and so on. So now that I have that, they are saying we need to find, they're saying, in fact, they're saying the coefficient of x is 7. Okay, so we're gonna deal with that. But we cannot choose this n over 2 as the coefficient of x, because this 3 minus 2x is being multiplied by that binomial, which I have now as 1 plus nx over 2 plus n minus 1 over 2 times x squared over 4. Okay, so now what I'm going to do is I'm going to look for possibilities where I can get the coefficient um, of x, right? And there's one condition. This negative 2 times this one is going to give me negative 2x. Can you see the coefficient of x here is 2, negative 2 rather. And then if I multiply this 3 with this one over here, okay, that is going to be plus, because of positive 3 times nx over 2, right? This is the only condition where I can get the coefficient multiplied by anything from that binomial to give me a coefficient of x, right? So we know that that coefficient of x is equal to 7. So let me just go ahead and let me just clean this up, okay? Without the coefficients. So this is going to give me minus 2x plus 3nx over 2. Now, what do I know? I know that the coefficient of x is equal to 7. So I'm just going to drop the coefficients, I mean the x's there, right? So I'm going to work with, let me just rewrite it as 3n over 2 minus 2. And I'm going to say let that equal to 7, because the coefficient of x is 7 according to the question there. They are saying to me the coefficient of x is equal to 7. Now I can actually find the value of n from there. This is a very simple equation now that you can solve. So this becomes 3n over 2 is equal to 7 plus 2, which is 9. Okay, so you should see that immediately. You should see that n is equal to 18 divided by 3, which is 6. Where is 18 coming from? That is 3n is equal to 18, that is 2 times 9, and then n equals to 18 divided by 3. Therefore, n is equal to 6. Okay, so that answers one part of the question. Now, the other part of the question, they say, and hence find the coefficient of x squared. So I'm going to come over here again. So I'm just going to rewrite that. Let me see if I have enough space. Maybe maybe over here. So I'm just going to rewrite that because of space. So I'm going to rewrite what I have. I know that 3 minus 2x, and then I have from before I have 1 plus nx over 2 plus n minus 1. Okay, I guess that's what it was it? um, let's just make 100% sure so that I do not lose out. And this is here, this is this part. In fact, can you see that here can still be changed, right? This can still be over 8. Okay, so I can write it over 8 as opposed to that. So n minus 1, n minus 1 is this part here, x squared over 8. Okay, n minus 1 x squared over 8. Okay, plus dot dot dot. That's where I'm going to end. So let me see, how do I get the coefficient of x squared? Now it can only happen if you multiply this term with that term. If you multiply this 3 with that term, can you see that? Also, that's all. That's all that you can do to find the coefficient of x squared. Now, let us see. But I'm going to only multiply the numbers. All right. So I know that the 3 times, so it's 3n n minus 1 over 8. Okay, let's leave x squared. And then the second one is going to be negative, okay, if you multiply the negative 2x here, so it's minus 2x times nx over 2. This is where I'm going to get x squared. So let's clean it up. So there's nothing here I can do. This is just 3n minus 1 over 8, that is x squared. Here the 2's cancel, leaving with minus, the 2's cancel, so minus 2n. So this is going to leave me with minus x nx squared. So that is going to be minus nx squared. Okay, 2's they cancel. Okay, so dropping the x squares now, dropping the x squares, and so I can find what is the coefficient of of x, right? I'm just going to all the way write it out there. Remember from our previous answer, because the question says hence, we know from our previous answer n was 6, so we are now go ahead and we are going to substitute that in. So it is 3 times 6 minus 1 all over 8 minus 6. And we can go ahead and grab our calculators, okay? So, but when we get our calculators, we're going to get the answer of 21 over 4, which is nothing but 5 and a quarter. All right, let's play over it, pause the video, go back so you can see exactly what I did. Right, let's look at question 2. Question 2, you have this very similar thing. The expansion of a minus x times 1 plus 2x raised to the power of n in ascending powers of x is 569x plus 2x squared, and so on and so on. Now, the question asks you to find the values of a, n, and q. And a and q are constants, and n is a positive integer. Okay, right. So where does it leave me? Right, I'll take the 1 plus 2x raised to the power of n, and I'll find the first 3 terms, right, using obviously what we have there. So I know it's 1 plus n, our x is nothing but the 2x, okay, this one that is over there, so that takes care of it, plus the third one, which is going to be n, open bracket, n minus 1 over 2 factorial, which is just 2 times 2 factorial, which is just 2, and our 2x is going to be squared, and that's all. Remember, just go up to the third one. Okay, if you want to, you can just rewrite it nicely for yourself. It's 1 plus 2nx, okay, plus, because that's a 4, if you have to square it, okay, this is going to be n minus 1 over 2 times 4x squared, okay, plus dot dot dot. Now, of course, what you should also know is that, of course, this 2 goes in here 2 times. All right, so at the end of the day, I have got 1 plus 2nx, okay, we're together so far, plus, then I have n minus 1 2x squared dot dot dot. Okay, so that's where I need to be. So now I can actually look and see what is it that I'm supposed to do. Right, so they are saying they're giving me the coefficients there. So what is it that I know? I know that a minus x times the business that I was doing now, 2nx plus n minus 1 2x squared. Okay, this is identical to 5 plus 69x plus q x squared plus dot dot dot. Okay, so I just have to clean the left hand side to see what is what is it that I need to do. But I can actually already see um, what my A is. The value of A is nothing but 5, because they ask you to find the value of A. You can see that the values of A will be 5, okay? Because it should be quite clear from that. But let us see. Let us multiply out. Let's multiply the A with everything. I'm going to multiply this A with that one. That gives us A. Multiply the A with this one. That is going to give us plus 2ANX. We multiply the A with all of this business here. Okay. That is going to be plus 2A, follow, then n minus 1, and then x squared. Now I'm going to do the same, but I'm going to multiply with the minus x times this one is minus x. Okay, minus x times this one, very careful, it's now going to be a negative. Okay, very careful, negative x. Let's just make x nicely here so you don't go like, who the hell is that, Mr. X? So this is an x over here, and minus x times that is minus 2nx squared, follow, and negative x times this whole business again is going to be a negative. Okay, that is negative 2n minus 1 x cubed, and so on and so on. Okay, let's just clean this up because there must be some like terms somehow. Take the coefficients and so on. A is A. There's nothing you can do. So A will be there. But 2an minus this one here, this one, and this one, they are going together. So I'm going to say 2ax minus, of course, let's go back to x minus 1, just the coefficient of the x, and then I put my x outside. Hopefully you are following. Plus, now let me take the coefficients of, let's take the coefficients of the square stuff. All of this square stuff, the one that I'm going to indicate on this, I'm going to take that, and the minus 2, that one. Hallelujah. Okay, let's do that. So we're going to have plus, so we have 2an n minus 1, follow. Now there is a little minus 2n here as well. So 2an n minus 1, just to make 100% sure, minus 1. Again, is it not so? Minus 2n. Minus 2n. All of this, the coefficient is x squared. I don't think I have to go on and on and on, okay? Dot, 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 dot. Because the q has got the x squared, so there's no need for the cube term. So I'm not going to even care about that last one. So what do I know? A is 5. We can see that. A equals to 5. Okay, maybe before I do that, so I have A plus 2an minus 1 x plus 2an n minus 1 minus 2n, this whole business, x squared, is identical to 5 plus 69x plus qx squared. Okay, now let's equate those coefficients, and that is why I was saying that A is equal to 5. A equals to 5. What is the next thing? 2an minus 1, yes, that one there, is equal to 69. What is the next one? The next one is quite a bit horrible, but we'll write it. Maybe I should use a different color pen. The next one is this whole business here. 2an n minus 1 minus 2n, that thing is, it is equal to q. So I'm equating coefficients. Okay, right. So we know what a is. So let's do the second one. The second one is 2 times 5 times n minus 1 is equal to 69. So this is going to allow me to find my value of n. So this is nothing but 10n minus 1 is equal to 69. So that is 10n is equal to 70. Then n is equal to 7. Okay, right. Now we're going to substitute in this one here, because we've got everything that we need, we know what is a, and we know what is n. So 2, a is 5, n is 7, 7 minus 1 minus 2 times 7. This whole business should give me q. Good. Let's see. Let's grab a calculator because it looks a bit horrible. So that is 2 times 5 times 7 times, this is going to be 6, all right, times 6, minus 2 times 7. What is q? Q is nothing, 406. Q, nothing but 46. Now we can actually answer our question. Okay, therefore a is 5, n is 7, and q is 406. Right, since I don't want the whole video to be too long, there are 2 more questions, and I'm going to do them on a separate video. There's question 3 over here, and there is question 4 over there. All right. Oh my goodness, there's question 5 as well. Let's look at the time. So let's do 1 more questions, and then we do the 2 other questions later. Okay. All right. So maybe you can have a sneak peek, and you can try this on your own. Pause the video, write it down, try it. I'm going to look at those questions tomorrow. I am a little bit spent here. We're going to continue with this tomorrow. That is question 3. And look at question 4. You can as well also write it down, where the expansion of 1 plus kx to the n, ascending powers of x is this and this and that and that. Find the values of k and n. So I'm pausing there so that you can take a print screen, so print it out and try it. Okay, and then we're going to look at it tomorrow. And then we have the last one. I can make it a little bit bigger so that you can see. Okay, that is the question over there. So you can print screen or take a picture of the screens, write it down, and then try it. Then tomorrow I have a look at that. Good.